All right, welcome. Today we're diving into the incredible engineering that keeps our railways safe. We always talk about how fast trains can go, but the story of how they stop, that's just as fascinating and honestly, way more important for safety.
Really think about that for a second. This isn't just a simple question. It's a massive physics problem that engineers have been wrestling with for more than 100 years. The sheer kinetic energy in a moving train is just immense, and getting rid of it safely and quickly is a huge, huge task.
So let's go back. The steam locomotive, invented way back in 1802, completely changed everything. It let us move people and goods faster and farther than ever before. But all that power created a gigantic safety problem that actually limited how fast and heavy trains could be. How in the world do you reliably put the brakes on these new iron horses?
Well, the first big solution was honestly pretty genius. It used the power of the air that's all around us. It was called the vacuum brake. Basically, the locomotive would suck all the air out of a pipe that ran the whole length of the train. To brake, the driver would just let air back in. That air pressure would then push on pistons in every single car, applying the brakes. Clever, right?
But yeah, it had some major flaws. On a really long train, it took forever for that pressure change to travel all the way to the back, which meant braking was slow and super uneven. And the braking force was limited by regular old atmospheric pressure, which just wasn't going to cut it for faster, heavier trains. Plus, that vacuum could literally suck dirt and gunk right into the system. Something had to change if railways were going to keep getting bigger and better.
So the next big breakthrough didn't come from creating a vacuum. It came from doing the exact opposite, using compressed air. This total shift in thinking led to a system so good, so reliable, that its basic ideas are still being used today.
And this is it, the automatic air brake system. Now, the genius here is how simple and inherently safe it is. A compressor fills a main brake pipe with pressurized air, and as long as that pressure is there, it actually holds the brakes off. To stop the train, the driver just releases air from that pipe. A special valve on each car senses that pressure drop and uses air from a local tank to slam the brakes on.
And this is the real game changer. The whole system is designed to fail safely. Think about it. If a car breaks away or that main pipe gets cut, what happens? The pressure is lost, which automatically triggers the brakes on every single car. This one idea completely revolutionized railway safety. It turned a potential catastrophe into a controlled stop and allowed trains to get longer and faster than anyone thought possible.
Okay, let's look at the numbers, because this is where it gets really stark. The difference is just staggering. At 65 kilometers per hour, air brakes could stop a train in nearly half the distance of the old vacuum brakes. And the equipment? It weighed less than half as much. Plus, they were way, way safer on steep downhill slopes. This wasn't just a small step up, it was a massive leap forward.
So we've got the power, right? The compressed air. But how do you actually use that power to create the friction that stops the train? Because, as you can imagine, the tech for actually applying that force has evolved just as much. Now, the early systems just pressed brake shoes right onto the part of the wheel that touches the track. The problem? All that heat from the friction can damage the wheel itself, and that's a huge, huge safety no-go on a high-speed train. So the solution is the disc brake, which you can see here. It's a lot like the one in your car. Brake pads squeeze a dedicated disc on the axle, giving you powerful stopping force without messing up the wheels. But you know how it is. The push for speed never stops. As trains got faster and faster, even those powerful disc brakes started to hit a wall. At super high speeds, the amount of friction you need is just insane. Engineers realized they needed to start thinking beyond friction altogether. And the solution they came up with was just so elegant. They decided to turn the very motors that make the train go into brakes that make it slow down. On an electric train, when you apply the electrodynamic brake, you're essentially flipping the motor's job. Instead of using electricity to turn the wheels, the train's momentum turns the motor, and the motor acts like a generator. And this whole process, it's called regenerative braking. Instead of just turning all that forward motion into useless waste heat, you're capturing it as electricity. And that electricity can be sent right back into the overhead lines to help power other trains on the network. You're not just stopping, you're recycling energy. It's an absolute win-win. And you can see that beautiful concept right here in action. One train slowing down is literally helping another one speed up. It changes the whole rail network from just a bunch of trains into a kind of cooperative ecosystem. It's an amazing way to reduce the total energy the whole system uses. But there's a catch, and it's a big one. Every braking system we've talked about so far, even the electric ones, relies on one critical thing, the grip, or what engineers call adhesion, between the wheel and the rail. And as this quote points out, that grip just starts to disappear the faster you go. So for the fastest trains in the world, you need something that doesn't need that grip at all.
And that is where the electromagnetic brake comes in. This is kind of the trump card for high-speed stopping. This system lowers powerful electromagnets down close to the track. They never touch it, but their intense magnetic field creates these swirling electrical currents, called eddy currents, right inside the steel rail. And those currents create their own magnetic field that pushes back against the train, creating an incredibly powerful braking force with zero physical contact. It's like an invisible hand reaching out and slowing the train down.
So, when you look at this whole journey, from a simple vacuum pipe all the way to contactless magnetic forces, you see this relentless, continuous drive for improvement. Every single one of these innovations wasn't just about stopping a little bit better. It was about letting trains get faster, heavier, and just fundamentally safer.
So the next time you're on a train and you feel it smoothly slowing down for a station, just remember all of this. The science of stopping that train is every bit as complex and as innovative as the science of making it go in the first place. It's this whole hidden world of physics and engineering keeping us safe. The only question is, what's going to be the next big breakthrough?